viewers. In today's lesson, we will be discussing about introduction to statistics. If you are new to our channel, kindly make use of the subscribe button, like our videos and share with your colleagues who would find it helpful. Tutor Bosun is here. Without further ado, let's move into what we have in this lesson. When we hear the word statistics, what comes to our mind? When we're talking about statistics, the first thing that comes to our mind is data. That is the study of data. We have a set of data, we want to study that data, we want to extract or bring out some information from that data. So that's basically what statistics is all about. So in statistics, there are some basic terminologies related to statistics. Some of the terminologies we're going to be discussing about include we have population, we have sample, we have data, we have parameters and the likes. So we have likewise, we have two types of statistics. We have the descriptive statistics and we have the inferential statistics. So the descriptive statistics deals with describing properties of data. Descriptive, as the word implies. So we want to describe the properties of data. And inferential statistics, inference, as the name implies, we want to draw conclusion from that set of data. That's basically what those two kinds of statistics is all about. So without wasting much of our time, let's discuss some of the basic terminologies we have in statistics. Like I have said, descriptive statistics, I've explained that. Inferential statistics, I've explained that. We have population, we talked about descriptive. Stats, we have the inferential, stats. Another important terminology is population. Population. Population is also another important terminology. So population, when we're talking about population, we're basically talking about the collection of elements of interest. That is the elements in which you are interested in. The entire people in Nigeria is the population. That will be a population if what you are interested in is the entire Nigeria. If the only point of interest is the number of Yoruba tribe in Nigeria, then definitely the number of Yoruba tribe is our population. If our point of interest is the number of mosquitoes that are produced daily or that are produced weekly, then definitely that will be our population. So it depends on our point of interest. Our point of interest drives the concept of population. Another important terminology is sample. We have sample. We have sample. Then we're talking about sample. Sample is basically a sample of the population. So we bring out sample from population. So another important terminology is the parameter. We have parameter. Parameter is another important terminology. So parameter is basically the summary of some aspect of the population as a whole. So that's basically what parameter is all about. We also have another important terminology which includes measurement. And I know that measurement is not a new term to us. So we have measurements. We're talking about measurements. Measurement basically deals with the number of attributes computed from the word computed. That's why it's called measurement. That is, you want to compute it, you want to quantify it. When you measure, you want to know the extent, you want to know the degree. So that's basically what that measurement is all about. That is, the number of attributes computed for each number of population or of a sample. So we also have another terminology, which is qualitative data. We have qualitative data and we also have quantitative data. These two, they go together. When we hear qualitative, then the next thing we hear quantitative. So they're similar but different. So we're talking about qualitative data and measurement. Both are measurements. Both qualitative and quantitative are some types of measurement. So qualitative data are measurements for which there is no natural numerical scale. On the word quality, when we're talking about quality, there is not necessarily a natural numerical scale. What we're trying to look out is, for the quality, is it quality enough? If your quality of concern is the color, is it having the right coloration? That might not be having the numerical scale. That might not be determined from your eye, your feel, and the likes. So that's why it's called qualitative data. But quantitative data will definitely be the opposite of qualitative data. Quantitative data will definitely be having a numerical scale that it can be judged from a numerical scale. So those are basically the simple terminologies we have under statistics. So without wasting much of our time, we'll be dealing with some aspects of statistics. Is the aspects that include the analysis, the aspect including our analysis. So some of the aspects we're going to be touching will include mean. We have mean. We have what we call mode. These are basically under the basics of statistics. So we have complex analysis, but we start with the basic ones. We have the mean, we have mode, we have median, we have range, we have standard deviation, we have variance, and less. So the aspect of mean, when we say the word mean, we are basically talking about average. So mean is the same as average. So mean is also divided into three types actually. So we have the average, which is basically we have the geometric mean, we have the harmonic mean as well. So we will be discussing about those aspects of mean. So like I have told you, mean is basically average. That is, you want to know when you have a group of data, that is, you want to take an average within that group of data. So that's basically what mean is all about. But when we're talking about mode wants us to know the number of elements or the element that occurs the most. That's basically what mode wants us. That is, if you have a set of numbers and 5 is the number that appears most, then definitely 5 is your mode. We also have median. So median wants us to know the element that belongs to the middle, from the word median. It is middle. And before before you can be able to determine your median, you need to rearrange the set of data accordingly in ascending order, that is from the smallest to the highest, before you can be able to determine your median. And at the end of the day, if you want to determine your median and you find out that two elements happen to be in the middle, then what do? You take average of those two elements for you to be able to determine your median. So I'm talking about range. Range is basically the smallest and the lowest element in the group or set of data. So we also have standardization, we also have variance. We have some other terminologies. We have deviation on its own. We have deviation, we have standardization, we have variance, and the like. So without wasting much of our time, let's take one example so that we can be able to touch some of these basic analysis. So let's have an example. So this example says the data obtained by measuring the age of 21 randomly selected students enrolled in undergraduate courses at a university could be presented as the data list. So in summary, the data I'm about to present to you represents the data obtained by measuring the age of 21. Definitely we have 21 elements in the data. 21 randomly selected students enrolled in undergraduate courses at the university. So these are the ages. We have 18, we have 19, we have 19, 18, 22, we have 20, we have 18, we have 18 again, we have 17, we have 19, we have 18, we have 24, we have 18, we have 20, we have 18, we have 21, we have 20, we have 17, and 19. So the number of elements in the data will have been given, even if it is not given, but that should be an int. It says 21 random selected students. Definitely number of elements here should be 21. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that's very accurate and correct. So let's say the question asks us to find the mean, which is the average, the mode, the median, the range. Let's start with those basic ones. So let's say, and like I have told you, before you can be able to determine this one, before you can be able to determine median, you need to rearrange those elements accordingly. So let's rearrange those elements first, to make it easier. So let's rearrange the elements. So let's say all the smallest element here, which is the smallest element there is 17. We have 17. We have 18. 18 occurs how many times? 1, 2, 3, 4, 5, 6, 7, 8. So we have 18. We have 18. 1, 2, 3, 4, 5, 6, 7, 8. 18 occurs 1, 2, 3, 4, 5, 6, 8. 8 times. 1, 2, 3, 4, 5, 6, 7, 8 here. 18 occurs 3 times. But 17 occurs 2 times. Can you take it? 17 occurs 2 times. So let's make that correction. 17 occurs 2 times. 19, 1, 2, 3, 19. So we have 19 there 5 times. What's the next higher number? We have 20. How many times does it occur? 1, 2, 3. 3 times. 3 times. So we have 20, 20, 20. 3 times. What other number do we have? What's the higher number? The next higher number? 22. How many times does it occur? Once. So we have 22. 22 occurs once. So what's the next higher number? The next higher number there is 24. How many times does it occur? 24 occurs once. 24. So now let's check if our elements are complete. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 20. So everything you skipped one element. Let's quickly go through that. Let's quickly go through that. 24 once, 22, and 2 occurs once. Okay. 20, how many times does it occur? 1, 2, 3. Okay. What about 19? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What about 18? 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 8. Let's check. 1, 2, 3. You have 3 here. 4, 5, 6, 7, 8. It is 8. You have 8 here. What about 17? Let's check how many 17s are we having. We have 1, 2. We have 2 17s here. In which element is the missing? Yeah, we have 21. We have 21, sorry. 21 is the missing element. We have 21. 21, followed by we have 21 once. Followed by 22, followed by 24. Yeah, so go to this. So now let's begin our calculation. So let's say the first thing we want to determine there is our mean, which is the average. So to determine your mean is basically represented. Your elements are basically represented as x. So your first element should be x1, x2, your second should be x2, the third should be x3, and so on. While your mean, which is your average, should be represented as x bar. X bar. So your mean x bar should be equal to x1 plus x2 plus x3 plus xn, by average up to infinity, So up to the point in which you have it, divided by, that's the reason why I represented it by xn, divided by n, capital N or small n. So n is basically your number, n is basically your number of elements present there. But this kind of formula is basically for data, for non-repetitive data. It's basically for what? For non-repetitive data. Or if you have repetitive data, you have to multiply each element by the number of frequency, by the number in which they occur. By the number in which what? By the number in which they occur. So before you divide by the total number or the total frequency or the total frequency. So you can do that, and you can basically take them one after the other, however the situation. So to take the mean of this, we have 17. So you can multiply 17 by its frequency. So let's see, we have so you can have this formula that you need to modify. Let's modify it. So you can have x1 f1 plus x2 plus x2 f2 plus x3 f3 plus xn fn. So x1 basically means theta 1, which is in this situation is 17. So f1 is basically its frequency, is not the number of points. So everything divided by the summation of the total frequency, the summation of the total frequency. So you can modify the formula. It can be written in several ways. So summation basically is definitely f1, f2 plus f3 and the likes. This time epsilon definitely means summation in statistics. So let's quickly have, so however the situation you do it, either you do it one after the other. What am I saying? That is, you want to sum it, you take 17 plus 17 plus 18 plus 18 plus 18, like that. But you might find that stressful. So that's the reason why we're introducing the idea of frequency. So let's say here we have x1. x1 is definitely our 17. What we have f1, that's equation. That is the frequency of something. How many times does it occur? It occurs 2 times. That will be 17 multiplied by 2 plus, what is the next element? We have 18. The next element is 18 multiplied by the number of times it occurs. We have 1, 2, 3, 4, 5, 6, 7, 8. It occurs 8 times. When we are counting, you should remember that it occurs 8 times plus 19. The next element, how many times does it occur? 1, 2, 3, 4, 5. It occurs 5 times. 5 times. So we have 19 times 5. 19 times 5. What's the next element? 20. How many times does it occur? So we have 20 times 1, 2, 3. So that's 3 times. Plus 21. It occurs once. So you can just say plus 21. Or you can say 21 times 1. 21 times 1 plus, similarly, 22 times 2 plus 24 times 1. Sorry, this is 22 times 1. Because it occurs once. 24 times 1. Sorry about that. Divided by the total number of frequency. And the total number of frequency should give you 21, like you said earlier. Should give you 21, that is the total number of data you should amount to that. But if you want to take the frequency separately, that is, this is 2, you should amount to 21. So 2, we have 2 plus 8 plus 5 plus 2 plus 8 plus 5 plus 3 plus 1 plus 1 plus 1. So everything should amount to 21. So our mean should give us, let's do our calculation. So let's do our calculation. Here we have 17 times 2 plus 18 times 8. Let's do that roughly. So we have 19 times 5. We have 20 times 3. Just take them bit by bit. There's no magic. So 21 over 21 plus 22 plus 24. this should amount to 21. Let's review that. What would I give us? Minus 5. Yeah. Just trying to review that so that we won't make mistake. Yeah. So our average amount is 19.047. We can write that as 19.05. So that's basically your mean, which is the average. Now let's talk about mode. I think we go to that mode. How did I explain it? I said mode is the most occurring, or the most occurring element in the So let's say, what is the most occurring element here? So let's check from here. What's the most occurring element? That is the element with the high frequency. So you don't even need to go and check. You don't need to go and be counting. Just check the element with the high frequency, then you get it. So what element has the high frequency here? So let's check. It's definitely 18 because the frequency of the thing is what? Is 8. So the frequency of the thing here is 8. So your mode is definitely 18. Not that 8. The 8 is just the frequency. It is the element that will be your mode. So element is 18. So your mode is 18. It will call 8 times. So we also have median. So median. So median is basically the element that happens to fall in the middle. So that's basically your median. So let's check what element happens to fall in the middle. So in order to be searching your data frequency, since you already know the data frequency, the total frequency is 21, which is an odd number. So when you remove 1 from it, it remains 20. When you divide 20 into 2, you have 10. So we just count 10 elements. Then the next element after the 10th element is your median. But if you happen to have 2 elements there, so what do? You take average of the 2 elements. So that is when your total frequency is not odd. That is when your total frequency is even. So that's when you're taking average. So let's check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is my 10th element. So definitely, if I have my 10th element to be here, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So definitely this is my 19 will definitely be my median. And that is the 11th element. Because after that 19, I can also count 10. Yes, definitely 19 is in the middle. So 19 is my what? Is my median. 19 is my median. So I'm talking about range as well. So what we are range? So our range is definitely 17 to 24. So that will be our range. That is the lowest element, which is 17, and the highest element, which is what? Which is 24. Which is 24. So we will also be discussing about standard deviation, variance, standard deviation and variance. And standard deviation and variance work hand in hand. That is, before you can determine your standard deviation, you need to determine variance first. Because standard deviation is basically square root of variance. So we'll be discussing about standard deviation and variance in the next example I will be giving. So let's quickly discuss about the standard deviation and variance. Standard deviation and variance. So I just want to leave an example separately for standard deviation and variance. Although in that example we can quickly recall to our mean, to mode and median. Although we will definitely be needing mean in standard deviation, we will definitely be needing mean, which is your x bar. So everything depends on one another. If you don't know the basics, you cannot know the complex. That's the reason why I'm starting from the basics. That is so that you can understand the core concept of this course. So if you don't understand the basic ones, or you may be feeling like these things are too basic, they are too simple. Mind you, if you don't understand the basic ones, you might be having issues when we get to the complex ones. There are still complex problems. We're still going to get to complex problems. These are the basics in which we need to understand. So, when we're talking about standard deviation and variance, as I told you, variance. Variance, which is given, variance to be represented as sigma squared or s squared, as the case may be. So we have sigma squared, we have our it might be represented as s squared, might be represented as sigma squared or s squared, although they are slightly different, but that's not what we are doing. We might be explaining that in the subsequent as we move on. So we have a sigma squared and we have what? S squared. Why is variance called sigma squared? The reason why variance is called sigma squared or S squared is that it is standard deviation that owns this sigma or S. And we already said that standard deviation is just the square root of variance. Definitely, variance will be the square of standard deviation. So that's why we are having sigma squared and we are having sigma squared for variance and sigma for standard deviation. So when we are looking at standard deviation, which is sigma squared, it is always given as so it's either we have 1 over n minus 1 over n minus 1 into this epsilon n I equals 1. What does this epsilon mean? It means summation. So now having epsilon, we're really getting summation xi minus x bar squared. Well, basically, so xi, what does xi mean? Xi means your element in the data. Like I've said before, x is your element, y is your what? Is your mean or average. Why can be having I? I can be anything. I can be 1, it can be 2, it can be 3 to infinity. So like I wrote when we were doing mean, we have x1, we have x2, we have x3 and the likes. So you can basically represent all of them by what? By xi, where I represents 1, 2, to infinity. So that's where we have xi here. So I means the summation starting from what? Starting from 1. You can never start from 0. So that's what is the rule is telling me, that is starting from 1 up to n, that is up to the point in which you want to fit that data, or up to the point where we have that, where we have the endpoints of that data. So the variance could be 1 over n minus 1, and it could also be what? 1 over n. So it can also be what? It can also be 1 over n. So we make use of 1 over n minus 1 if the total number, if the total number is less than 100. That's when we make use of 1 over n minus 1. Please take note. So we make use of this when n is less than 100. Why we make use of this? Why we make use of 1 over n into summation n I equals 1 xi minus x bar squared. They are basically the same formula, but anytime you have capital you change it. When you have n minus 1, change to n. So this is when n is greater than 100. this is when n, if n is 100, I think this is when n is less than or equal to 100. When n is less than or equal to 100. So if you still have n as 100, you can still use this. But when it is greater than it, then you use this. Let's quickly move to what we have. So this is variance. So what will be our standard deviation? So from what I have taught so far, standard deviation. So standard deviation is sigma. I want sigma squared again. So what we have sigma, which is definitely was on the square root, sigma squared plus sigma. It should now be the square root of everything here. Square root of everything here. So here we have what? Here we have 1 over n minus 1 summation n I to 1. So we have xi minus x bar squared. So that's what we have there. So as usual, if n is less than 100, so make use of this. Or if n is greater than 100, make use of this. Make use of this. So likewise, or you say or the square root of 1 over n into the summation of n I to 1 over xi minus x bar squared. Xi minus x bar squared. And depending on the situation. So here is when n is less than 100. So here is when n is less than or equals to 100. When n is less than or equals to 100. So now let's take an example on that. So this question says you should consider the table below. So from the table, you have to determine the variance, the standard deviation, and which along the line will be determine the mean as well. So even if you are not asked to determine mean, you'll be needing mean. Why are we needing mean? Because take the formula, look at the formula, grabbing x by the formula, and what's your x bar? Your x bar is basically your mean. So this is the table given. Let's start with example 2. So let's go ahead and example 2. So, like I've said, I probably should have said the difference between sigma and s. So sigma is used when we are not subtracting 1. Sigma is used when we are not subtracting 1. So while s is used when we are subtracting 1 from it. So they are the same thing. It is still the same standard deviation, but the sign of representation is different. So basically, we will call this s. Why we call this sigma? This should be well represented as, or let us say accurately represented. So we can say this is s. Do the same thing. So let's call this sigma and let's call this s. Let's call this s. So let's change it as well. Likewise, so this is s squared. This is s squared. And this is what? This is sigma squared. Although all these things doesn't matter. The most important thing is for you to understand the concept. Nobody will penalize you for using those things. S instead of sigma or no. Once you define it, like this is what you can represent your own standard deviation and anything. See, one thing about mathematics or engineering is that there may be several approaches to things. Just make sure you define your own way. You want to represent your mean. Someone might not represent mean as x. You might choose any letter. You might use z bar. Just define it as letting my mean to be equal to so thing. So then and we go to, though it depends on the examiner. Some examiner want it the way they give you in maybe lectures or whatever. While some are quite understandable that okay, this guy has defined what he meant by this symbol. So let's come to the example. We're given a table, so we want to bring out some information and we want to do some statistical analysis on it. So we have serial number. This is for serial number. We have serial number there. We have the permit. We have the permit. We have attendance. Attendance in class. In class. And that's X. That's X. Why is that assigned as X? Remember, that it is really X because that's our point of interest. So everything that will be here is not none of our concern. We might be leaving some of them, but our main focus is this X, which is the element in concern. So we have total number of students. We have number of students. We have rate of attendance. Rate of attendance in percentage. We have rate of attendance in percentage. Rate of attendance in percentage. So that's basically what we're giving. That's basically what we're giving in the table. So let's record down the values. We have not recorded down the values. So we have 1, we have 2, we have 3, up to 7, 3, 4, 5, 6. Okay, let's bring it down a little. 6, 7. So the permits, what are the permits? We have CPE permit, which is computer engineering. We have AG, which is agricultural engineering. We have EEE. We have ME, which is mechanical engineering. You can wherever. Just deal with the information you are doing. We have CHE. We have CVE. I have FD. So these are basically for engineering departments. That's clearly. So attendance in class, CV has 37. So AG has 35. AG has 35. The total number of students for them, we have for AG, we have for CP, we have 150. For AG, we have 147. The rate of attendance, here we have 24.67%. We have 23.81%. So for EE, what we have? For EE, we have 48 for attendance. So let me just run through the table. So I won't waste much of our time. We have 29 here. We have 53. We have 23. Here we have 27 students, 27, 210, 70, 246, or 41.43%, we have 21.54%, we have 54.76%. So that's the table. And here, you definitely have the total. You have the total here. So total for each. So we basically needing this column. Also you need the attendance and you need total number of students for all the estimation or calculation you want to carry out. So what we need total number of attendance, total number of students. Example 45, 48, 20, 29, 23. The total give us so for let's begin it, let's begin it afresh. In an exam situation, you might not be given that total number of students, total number of attendance and total number of students. You might be the one to do that yourself. Why, some standard questions might be given the total already. So let's assume we're not given. We always prepare for the worst in exam situation. So let's solution. So what do you do in this situation? This is the question you're going to be given. And you cannot just be solving everything inside the question. No. You need to redraw the table as your own, and that will be the first step of your own solution. Let's redraw the table. So let's redraw the table. So you have serial number, you have department, you have attendance in class, X, attendance in class X, you have total number of students, I won't be reading this column, but we may include it when you do your own. So I'll be explaining it here, so because I won't be reading it. So we have total number of students, we have, and the additional column you're going to be creating should be for deviation. So you might have an additional column for your deviation, and you should also have an additional column for your square of deviation. So when we're talking about deviation is D. It's always represented as small d. And what do you mean by deviation? That is, you take your average. Deviation D is basically represented as xi minus x bar. So that's basically your deviation. So square of deviation is basically square of this. That is this square. You square everything. So before you can be able to determine your deviation, technically you'll be needing your what? For me, this is x bar. So deviation which is equal to xi minus x bar. So your deviation square, with this square, will now be what? Xi minus x bar square. Why are we needing this? Because we check our formulas, we have the deviation square, this square. So everything here can basically be represented as this square. So that's the reason why we'll be needing that. And one thing about statistics is that make sure you maximize the advantage of your table. Maximize the advantage of your table. Instead of doing your analysis separately or manually, or how would I put it? Make sure you do everything possibly on the table. Then you just start to drag out the information and input it in your formula. So serial number we have 1, 2, 3, 4, 5, 6, 7, and here we have total. So we're including the total in this case. So the down we have CP, AG, we have EE, D as well. So here we have 37 students, we have 35 here, we have 48 here, we have 20 here, we have 29, we have 3, and we have 23, and the last part. So total number of students, we have 150, we have 147, 147, we have 27 as EEE, we have 210 as MEE, we have 70, we have 247, 246 rather, see we have 42, we have 42. So what we have total, so we needed the number of tenants, what we have number of tenants, we have here we have 2, 4, 5. You can press that in your calculator. It's definitely 245. So what will be the total number of students for each determinant? You can also put that in your calculator. And please, you need to be very, very careful when solving problems in statistics. You need to be very, very careful. Make sure you put the right thing in your calculator. Because any slight mistake in statistics definitely nullifies everything you've done. Because you may be needing those values you've gotten, you may be needing it in further calculation. Not only in statistics, but basically in every area of mathematics. You may be needing some of the initial values in further calculation. And once the initial value is wrong, you may miss the subsequent calculation. And it's not all the examiners are so considerate. You know, some examiner will just look at your step that okay, say he got the answer wrong, but okay, let's give him some mark. Let's check this step. Some you might lose all the mark, the entire mark, and some examiners you understand? So you need to be very, very careful. So before we can be able to examine our team, remember we're reading our expert. What's our I? Our I is definitely our xi is definitely the attendance, which is x. So your xi, your x1 will be serial number 1, x2, serial number 2, and the likes. And as you can see here, this is not repetitive. The data are not repetitive. So if the data are repetitive, so you employ the idea of frequency. You employ the idea of frequency. That is, you can't just do everything directly like this. You need to introduce a frequency. And how do you do about that? After you've done your derivation, you multiply by what? You multiply by frequency. Multiply by frequency. So and if you are doing the mean as well, if you are looking for the mean, that is the x bar, you make sure you multiply determinant by frequency. I've taught that in the previous example. So now let's determine our mean before we can be able to complete this table. Let's complete our mean. Let's complete our mean. Let's complete our mean. So our mean x bar. Our mean x bar definitely was. So the mean, we are looking for the mean of x and not the mean of total students. Please take it. So don't you are making use of total students as your as your n or as your total frequency. No, you are dealing with don't where you are dealing with x either x. Don't move close to the total students at all. Are you with me? So don't move to the total students. So we are dealing with attendance. So to determine our mean, which is x bar, which is definitely summation xi, and in determining frequency, that is, if it is repetitive, it will definitely be what? Summation xif over summation f. But here, you know, it's not having frequency, so just summation xi over what? Over n. So summation xi over n. And n is obviously what? Be the total number of frequency of attendance. Total number of frequency, not total number of students. Is our as I said it earlier, our point of interest here is not the total number of students, but attendance, which is x. That's why x is here. So our point of interest. So anything you're going to be doing won't be involving total number of students, but what? Will be involving attendance. So the total number of students here, that column is just there to confuse. So likewise rate of attendance. So you may be asked questions on them. So that's the reason why I did repeat rate of attendance here. Same thing applies to total number of students here. So you won't be needing it. But it's better if we included it so that the table won't be empty, so that it makes more sense. So here we have x bar, summation xi over y. If we have frequency, summation xi f, that is whatever frequency over y. N is also your summation f, that is summation of frequency. You understand? So here we have everything is not repetitive, that is the frequency is 1 1. So 1 1 1 1 1, that is 1 plus 1 is basically 7. So your n is 7. So here we have summation xi. What we are summation xi? The total number of attendance. The summation, don't let me say total number. Summation of attendance is what 245. So here we have what 245 over what? Over n, which is 7. And that is really was what? 35. That is 35. So your x bar is 35. Your x bar is 35. So you can now calculate your deviation. So now let's compute our deviation. So our deviation for the first one, d1, will give us what? That will be xi minus x bar. What was our xi in this situation? Our xi is at 7 minus 35. That will give us 2. So there we have 35 minus 35. What do we have here? We have 0. So we have 0. So we have 0. 0. You can put it in 2 decimal place. You can say 0 is 2.00, 4.00, 4.00. Here we have 48. 48 minus 35. What do we have? We have 35. We have 13. We have 13.00. So that's 20 minus. Is this visible enough? 13.00. So here we have 128. So here we have 20 minus 35. What do we have? That's minus 15. It should be minus 15 because 20 is smaller than 35. So it should be minus 15. That's the reason why we have the square here. The square here, the function of the square here is to cancel out the negative. Because some will be giving you negative. Although in some formula, instead of the bracket here, they include modulus. Then you should know the meaning of modulus that is without considering negative signs. But you don't need it here since you will still be squaring it. So all negatives will cancel out. Negative squared gives you what? It gives you 1. So it gives you positive. Let me put it that way. So here we have what? 1 minus 15.00. So 29 minus 35. What we have now is minus 6. It is also less than 35. Minus 6.00. 53 minus 35. What we have 15.00. So 42. Likewise 42. Likewise 42. What do you have? 42 minus 35. We have minus 12. 2 minus 12. 12.00. Oh, sorry. 23. 23 not 42. I'm already going to the wrong way. So we have 23. 23 minus 35. So we have minus 12.00. Minus 12.00. So that's everything about our derivation. So please, you need to be very, very careful when computing it. Don't go to the wrong data because we are having similar things that might confuse you. Just make sure you stick to this. Make sure you and even cover it so that you won't make a mistake. So we have gotten all our derivations. So now let's complete for the square of our derivation. So 2 squared definitely give you 4. So we have 4.00. 0 squared definitely give us 0.00. So we have 13 squared will definitely give us 169. So we have 169. So what's that? 15 minus 15. But the square will have cancelled the minus. So just say 15 squared. So 15 squared give us 225. So 6 squared should give us 36. So 15 squared gives us what? 324. And 12 squared gives us what? 144. So those are our derivations. So we can now calculate our variance and standard deviation. Variance and standard deviation. So our variance and standard deviation. Before you can determine your standard deviation, you need to determine variance. I've already explained that several times in this lesson. So variance and your n, is it less than 100 or greater than 100? In this situation, your n is what? Your n is 7. You take note. Your n is 7. Because these data are not repetitive. And how many of them are there? 7. So your n is 7. 7 is far lesser than 100. 7 is far lesser, so it should be what? It should be n minus 1. Formula I'll be using will be n minus 1. So variance and the symbol we're going to be representing is what? Is it S or sigma? It is definitely S. It is greater than 100, that's when we use what? We use sigma. We have S, and that's S squared, which is equal to what? Which is equal to 1 over n minus 1. 1 over n minus 1. We have what? Summation I equals 1 to n into xi minus x bar squared. Xi minus what? Minus x bar squared. So now let's complete. So that's 1 over 7 minus 1. 1 over 7 minus 1. And we haven't summed the total. No, we really sum. It is actually summation. So the sum of your deviation, will be needed. So let's sum everything together. That's why you need this table. To generate everything you need. So if you sum everything together, you do that very well. You do that using a calculator. 4 plus 169 plus 225 plus 36 plus 324 plus 144. Now, so I'm not actually bringing those values from nowhere. So I'm actually computing them. So we have 902. So once you compute correctly, then you are good to go. So your summation is 902. So here we have what? We have 902 over minus 902. 1 over 7 minus 902. So what would that give us? What would that give us? 7 minus 1 is 6. So that means this is basically 902 divided by 6. 902 divided by 6. So that should give us 150.33. 150.33. So that's variance. So what about that derivation? That derivation, which is basically S, that is square root of variance. Square root of variance, and that was square root of This is your variance now. So this is 1 over n minus 1 summation n I equals 1 xi minus x bar squared. So what we have square root of 1 over 7 minus 1. Though you might just have said square root of 150.33, but some examiner prefer showing your workings. Don't just jump into the conclusion. So we have what? Time 902, which is basically square root of 150.333. So that will give us what? That will give us square root of 150.333, and that will be 12.26. That's 12.26. So guys, at this junction, we will be coming to the end of this lesson, which is basically introduction to statistics. So in the next lesson, we should be moving into some other aspect of statistics. Particularly, we should be anticipating probability theory. So we will be discussing about probability theory. So if you are new to this channel, make sure you subscribe, like, and share the video for those who will find it helpful. Thank you very much.